Коллеги Валерий Попов и Николай Чадаев.
And we can start now. Valery Popov and Nikolay Chadaev will speak about building of protected database clusters with the use of mandate access. As an introduction, I'd like to say that Postgres is a very safe database, and there are a lot of materials devoted to this subject, but in this work, Nikolay and I considered additional safety tests. They are possible due to mandatory access control. So I'd like to show you several boring slides, and after that Nikolay will speak about the way it functions. Probably it will be more interesting for you. Information security is the obligation of information holder, and the main purpose is protection from unauthorized access. This protection is provided by the system of access control that can include several access methods. I'm speaking about the access in terms of roles. This is discretionary, mandate, and role access control methods. The most popular method is discretionary access control method. It is based on access matrix. In operating systems, this is reading, record, and execution. Database has 11 of them: select, update, insert, delete, truncate, reference, and so on. And the last one is usage. And role and discretionary access control methods are characterized by the fact that access of subjects to objects is defined on the basis of access matrix. A drawback of this approach is that when there are a lot of objects or subjects, and it is difficult to manage them. And an important drawback is that the possessor or the subject that has a right to an object can transfer this right to another subject. Here you can see two examples related to access control in DBMS. So this right can be transferred or revoked. Actually, there are 11 of them. And mandatory access control is based on the safety features possessed by every object and subjects. And the rules of comparison are specified in system policies that are obligatory for all the users of the system and for all the applications. This is the difference between mandate, discretionary, and role access control method. The mandatory access control method is obligatory and it cannot be changed. The policies implementing mandatory access control are numerous. These can be role policies and many other things, but in terms of Russian specificity, regulatory documents require to have a multi-level system that is composed of hierarchic levels and non-hierarchic categories. This is MLS MCS model, multi-level security, multi-category security, and mathematically it can be described by Bell-LaPadula model. If there are access levels, then it is not possible to read an information located at a higher level than your level is, and it's not possible to share confidential information to a lower level. SELinux, SELinux is an implementation of mandatory access control in Linux operating systems. Actually, there are several of them, but SELinux is most popular one. It is maintained by Red Hat and Russian operating systems that are certified. Among Russian operating systems, SELinux is the only one that had created its own system of mandatory access control. Its name is parsec, but we will not describe it now. Our work was based on SELinux. And actually, SELinux is a system that is somehow similar to database. That is a setting above the operating system. It has its own users, and these users have a set of accesses that are described in the system policy. These policies are throughput for the kernel, the application, and the database. And when receiving the access, the application checks system policies. If the system has mandatory access control, then the access to the object is provided in case of simultaneous permission for discretionary access control by the operating system and mandatory access control. And if discretionary rights do not authorize access, the mandatory ones do not even start considering these requests. SELinux is a subsystem, so it's necessary to check the users of the operating systems and the users of SELinux system. Postgres has a module known as PGCL that is a dispatcher of access to database items. It checks the policy of the operating system. In this scheme, you can see this principle of interaction. When users make queries to a database using sepgsql module, they address the kernel, and the kernel authorizes or doesn't authorize the access in accordance with the system policy. After that, access to the objects is provided. sepgsql is actually related to a number of limitations, and it does not have access control on the level of strings. Starting from 9.5 version of Postgres, there is RLS, that is role level security, and here you can see an example. It is actually defined by policies of access. So this is one and the same table. You can see that various users can see it using RLS, and this mechanism is very flexible. It allows to implement any access policies, including MLS, MCS, and so on and so forth. But the main meaning of this work and the main task is not to emulate mandatory access control inside DBMS, but during the work with system policies of the operating system. And of course, regarding network interaction, I'd like to mention that it's also very important. Within the host, it is possible to arrange for tag transfer from one user to another. It's possible to make a mandatory partition, but you need to have a network setting that allows the users to interact with tags transfer. We implemented it through net label mechanism, and the main comment that I would like to make before giving the floor to my colleague is that DBMS doesn't have mechanisms for storing and assigning labels of the users. This mechanism is implemented by the kernel of the system. A subject in the database gets their context of security from the operating system. So, it's quite similar to the way we map a user of operating system on SELinux user to get mandatory access control rights. And a user that comes to the database gets specific roles inside these DBMS. And now I'd like to give the floor to my colleague Nikolay. Hello. I will continue the presentation. My part of the presentation consists of the following items. I will speak about the subject matter. After that, I would like to speak about mandatory access control and the way we configured the system. We tested it, and after that, we evaluated the advantages and the disadvantages of the solution. So, the subject matter. This subject matter is quite sophisticated. You cannot take production base just the way it is, taking into account data protection. So, we took a demo base related to air freight. This was the basis for protected solution. There is a heavy variant, a large one, that include data for year regarding air tickets sale. Logical model of the base. It is very simple. So, this is the logical model of the base. Bookings. Here you can see the category of security. Tickets. In the booking, a booking can actually include several tickets. One ticket can be related to several air flights, transfers, for example, and boarding pass. That is number of the ticket, number of the seat, and all other information is for our reference. Speaking about the subject matters, there is a category of passengers whose personal data, the facts on ticket purchase, flight, and seat in the plane should be protected. So, the access of the company's personnel to this data is limited. Only specific authorized individuals have access to these data. And there are two categories here. S0 is open data, S1 DSP, and S2 are secret data. It means that only limited number of people have access to them. So this is not an open access. This model is quite relative, just like any model, but we had to start with something. So, this is our solution. CentOS 7.6. SELinux was already described by Valery, but we also needed multi-security policy. It provides for multi-level security. sepgsql is a monitor from Linux in Postgres. We selected Postgres Pro Enterprise, although here it is. Although we could use vanilla and standard, it's not important here. RLS policy. It was mentioned already, and in principle, we have to store the string labels somewhere. So, I'd like to speak about it. sepgsql. Here it is. So, we installed it, we launched Postgres, we called the function for the base allocation, and it put security labels for all the objects, the base, the schema, the sequence, table, column, and string. And I'd like to say that the labels of the base, the labels of the table, actually accept storing various data.
Метки объектов базы. В PGConf.Russia есть
Where do we keep labels for databases? There are several dozens of thousands of records. With strings, it's more difficult. This type is written into the policy, but there is no space to store it. So if you read Wikipedia, you will see that this is considered as a customer area. So we have selected to store them in the database, but in the applied area, and not to mix it with the air traffic database. How to store a label? This is the most painful question. There are two ways. There are publications covering this. One option is to keep the security label in the string itself. There is another option to store all labels in a dedicated storage, similar to access control list concept, where labels for other objects are stored. So we went for this option. The relative diagram is like this. So parent object name of the protected table, a global ID, string ID. This is a thing that is related to a protected table and the security label. And then comes the string label. Nothing special. This structure must ensure a very simple query plan. Physical implementation. Yes, we have a separate arrangement called sepgsql sequence for generation of identifiers. So the strings must be related or linked with labels. So the table is sectioned by the name of sections, and the name of the table is part of the primary key. Very simple structure. So the question is, what will happen with the applied table and applied database? Remember the relative scheme. There are 5 entities with labels, but what will happen to them? Here is what will happen. So an additional column is introduced in each table. Global identifier rec ID, so it has a name by definition and is protected from doubling, from being doubled. So the reverse side of this technology is that the database begins to expand because it includes the storage of labels. Storage of labels turned out not to be enough. Dozens of functions appeared, separated by types, classes, you name it. Get the label of a protected object. If you write a request each time for that, is very tiring. Set the protected object label. Create the string label. Check and create are the important functions. On their basis, we create RLS policies. So how do we create a string label on the basis of the security label of a table or a client? So the client brings its security level to the string. Check is comparison of client labels and the string labels. Auth is not anything new. It's not reinventing the wheel because discretion rights are ahead of the SELinux. It's important to understand what they restrict. If something goes wrong, what do they have inside of them? And secondly, if you keep the label in the string, you should restrict access of users. Trigger functions. They process events through insert, delete, and update. So, for instance, you enter a string and then a label is created in the storage for this string. Valery spoke about the RLS policies, but there is one interesting feature. As compared to Bob and Alice examples, we built our RLS policy on the basis of security labels of SELinux policy. This is important. A few words about the policies. Using expression for the existing string with check for the new string, we have 4. Select, insert, update, and delete. Very classic. And this is a note. We need to link 2 things, RLS and the SELinux policy. Definition of a policy for the selection. So we assume that we always have this available. The user has this table available at all times. Insert policy. It's important. Create function. So it takes the client security context and the parent table security context where the string is inserted. This is the name of the table. So create a dot, and this dot should not be empty. Update and delete. It's more interesting. First, we analyze the condition of visibility. Is it possible for the user, and the user is always present, the user of the database to which a security label is assigned. So this user is always present in any session. If it is open session, so the user is always present. And the second one is with check. Is it possible to have the operation of update for this user and for this table? These are discretionary rights. SELinux policy may have a read-only policy for the user. So the user cannot modify data. It is prohibited. All functions are written on SQL and PGSQL. And here we need something different. Here the function should refer to the current policy settings. This is the foreseeable future. The same for delete, for the delete policy. Subject and object. I spoke about the user and the table. So what happens? The user who was present in the previous slides, just behind the screen, it joined the database. We made a simple query. This is a regular and most frequently used function of sepgsql. We tested it. So the user is single. This is the row, this is the user, the type, and the label. Briefly, row includes several types. Staff R includes system T and a couple more. Type relationship defines the policy. Let's assume that this is a yellow user, S1. So access control is higher than open, but the lower than open. So this is the table. So the user has access to this table. Moving on, let's have a look from inside of the system and from bottom to top. So we made a simple query. Here are 3 strings of the table. So plane ticket bookings. price, date and code. What are the labels? See the upper part of the slide. This is rec ID, and for those 3 lines, 3 strings, the labels are present. Line 1 and line 3 are open data, and line 2 are related to DSP data. Very well. This is the user makes a query. You see the 3 lines. It has the rights to DSP type data. Remember the Bell-Padua model? It always has reading rights to its own level and below, but not higher than its level. It will never see the confidential data of S1, but it can see the first 3 lines below. One more user 0. By its name, we can see that it has access only to green open data. It sees the first 2. It sees line 1 and line 3. It cannot see line 2. I'm not talking about reading, recording, and deleting. But let me briefly mention that it can write at its level and above, but it can read only at its level and below. So 40 minutes is very little to speak about the solution. So what needs to be done to set the components that we obtained to make them work? CentOS, Linux, Postgres, and apply database. CentOS. It all boils down to installation of additional packages. NetLabel tools, this is mandatory. This is the framework to control label transition across the network. Sometimes the guidelines are sophisticated. You may even find Russian translations of those guidelines. Policy MLS, clear. Utilities for control, and Postgres itself. We don't do anything else here. It's important to set SELinux. This is the main setting file, SELinux config. So at the time of development, we move it to the permissive mode. It means that any security violation is registered in the audit log, and the violator may continue doing its work no matter what. Then we say that we have the MLS policy, because originally we assigned the targeted policy, the most frequently used policy in Red Hat. This is the security policy. Now we need to label everything. Without launching Postgres, we need to relabel the full operating system, because each policy has its set of types, roles, and labels. So we create an empty file. We can even say it is -F, and then we reload. So CentOS will warn you that a lot of time is needed for relabeling. That's fine. So status. So this is a frequently used utility, MLC, permissive mode. Good, so we will not come back to it. Postgres settings. The simple things. Shared preload, we say sep PGSQL, and then we do service restart. So what do we get? Now Postgres is in action. The process tree, this is enterprise, so you can see the commands. Red color shows security of each process. So the role and the user are on top. It will be repeated. All processes operate in the same context. INIT, level from 0 to 15, category from 0 to 1023. It is all in compliance with the MLS policy. It's important to verify this, because if you have C0, that means you said something wrongly. Further on, we created two extensions. One is PG Pro SELinux. This is a wrapping on top of four regular functions of SELinux in CPGSQL. Why do we need it? It's an additional guarantee that as we recover the base database from dump, the security environment will be maintained. As far as the second extension is concerned, it is bigger, PG Pro MLS SELinux. This is the storage arrangement. This is the function that ensures the storage arrangement. And an additional functionality. Extensions are not enough. Installation scripts are necessary. Why do we have them? There are three of them. Number one is needed because it installs additional security labels on functions, on the functions that we wrote and that are used for management. Why do we need additional labels? Because they will have special rights. You will see that. So it is included in the regular delivery. Two other depend on the protected database and its structure. The first ensures modification and storage of the applied database, and the second one creates users and additional discretion rights. For the sake of coding, in their name they have extension version number. It is number 3 in this case. Why do we need the first extension? Because some functions are performed by a trusted context. What is it? It's an approach of Linux bands, similar to security definer function. You launch it, and it supports the full base. So extension machinery does not support security label. So those commands are put in a separate script, and it should be launched after the extension installation. The second post-installation script is like this. So what do we do here? So we are turning the applied database, we create additional sections in the label storage, we modify the applied tables, I mentioned that. We install labels on the tables and sections. This is standard. We create string labels. If these are tables with data, we create labels for each string by default. We link triggers and applied tables and create the RLS policy, most importantly. This is a specific script. If there is a big production base, it will be broken into several units, but the point, the essence will remain the same, like you see. And the last one, here we define main roles of Postgres. We recall rights from the pseudo role of public and add additional discretion rights if they are necessary. This is about it. It looks like we have done everything and it should work. It was about the role of the database and the role of Linux. A small thing, a small nuance that will be very critical. This is a fragment from the last post-installation script. So you create a number of users, a set of users. Those users with those names should be present in SELinux. Why? Because the approach is very simple. Linux user equals the database role, and the selected SELinux user with a certain security status brings us to this SE logins. So each user gets its context. That's where it comes from. And this context is assigned to the database. The user, we have them, then you select the necessary one, the appropriate one. Sometimes you need to select them, but on a rare occasion. So Linux is linked to the Linux user and the security context. That's all we need.
So we called this function and received the label. It's really important because for the most existing systems with mandatory access control, use this rule: one login in operating system and one role in the base. And in Lustre and Parsec, we have a similar picture, but there is a different approach. When one login, one role in Linux responds. Well, I'm sorry, I got confused about. One login in Linux responds to many roles in the base. And we should be possible to dynamically switch them. So the documentation has this information regarding PGCL. So it is possible, but we haven't used it. And now, testing. So the initial stage was passed, we devised the solution, we created policies, and what will we have in practice? The assessment of performance. We have a triple impact here. We always have sepgsql, RLS, with its own limitations, and we also have an additional feature that is centralized storage of labels. So, how will it influence the performance? And what remained outside, that is load testing and real load. Yesterday we heard a good presentation devoted to load testing and an attempt to reproduce a real load. This was a cloud solution, but the approach was appropriate. This is a simple query. The data are open. The user has a right to get access to open data. It's necessary to select all air tickets for a week with specification of time till the next flight. This is a ticket to several flights, a transfer, or a flight back. The booking table has 2 million strings. We launch the query and see what's going on. So the top one is with RLS and the bottom one is without RLS. 10 strings. That is a bad result, 7 minutes and 9 milliseconds. 15,000 times slower. So we started thinking about that. What can we do about it? Let's look at the query plan. This is the actual time. It is really large. Now I'm just ignoring the fact that the planner selected the function from the policy in the first place, and that's why in the table in 2 million lines we have to scan it consecutively, and we ignore the index, the search index that had just been created. This is something we should work with. Large actual time. So we started thinking about that and developed the following solution. We divided the security label. That is about architecture modification. The user role and type are in the storage, and sensitivity and category, that is S0, C0, are transferred to the applied table. So the applied table has another column, and new functions are here. So what do we have? First of all, the policies changed. That is important. Select policy is to be very fast because it is about this function only, and that is an address to the kernel from the Linux, and it checks the security label in its screen. And here you can see the old option of the policy that addresses the central storage. Okay. The policies of update and delete are 50 by 50. At first, they select the visibility in a fast way, then they select the operation fulfillment. It was not really fast, but we don't need it now. So we launched the query. It was 81 times faster. So we managed to cope with it, but still the difference is so huge. What else is there? I marked red another problem. The function of the policy, even an updated one, this is an updated function, and the planner puts it on the first place. At first, it consecutively selects all the strings, and after that, it fulfills search on the basis of index, and we will do it in the opposite way. The solution. This equation is substituted by hermetic function call. Only the function of this type can be put by the planner before the condition from our list policy. And here there should be no modification of type leak prof. Indeed, the text of the query has changed. In red, instead of this equation, you can see the call of function. So we launched it, and it is better 30 milliseconds and about 10. So we stopped here. What are the conclusions? And actually my presentation is close to the end. I'd like to mention that this is a trial, an experimental solution. It will develop, and we think that it can become successive. This is a compromise between stringent storage of confidential data and distributed schemas for label storage. The functionality of PGSQL module is expanded, and you could see it. There used to be 4 functions, and now there are 20 of them. And what else is important? In our work, we used these materials. The first one is MLS Postgres. These are open materials. They were published on PGConf 2016 and on PGD in Paris 2017. And the second one is related to the network management and the use of NetLabel framework. I'd like to thank the authors. This was really helpful. Okay, do you have questions? Thanks a lot for your presentation. We have about 5 minutes for questions. Hello, thanks a lot for your presentation. And in real applications, there is a typical situation. When pool of connections is on, there are a lot of connections of one and the same user. And you need to define the real roles not on the basis of the Postgres user that was used for connection, because it will be actually similar for all the end users. But it's necessary to estimate the role by the rights of the user that was not introduced as a Postgres user. Well, yes, I mentioned that. sepgsql set.com, we can set context, that is dynamic setting of context, but it was not used here. And the things that I've seen, the security models, I mean the protected database, they always have these strict division. But yes, this function exists, so it means that it will be necessary to introduce Postgres users. Well, we have one Postgres user, but we have several roles in the base. Do I understand you correctly? Well, probably. Maybe you can discuss it behind the scenes. Okay, because we can discuss it. Another question. You showed it using 11.5 version, and if we have Postgres Pro 10.3 certified stack, can I implement it in my version? Yes, no. You're not able to implement it because the certified version is compiled without support of sepgsql. And separately, well, you need recompilation. Okay, and how is it possible to implement it on 10.3? You can't implement it on the certified version because you will need recompilation. And you know what the consequences are. But it can be implemented on any version, but you need to compile it with sepgsql key SELinux. Yes, that's what I meant. That's what I actually meant when I said that you can do it. Actually, the session definition will be a bit different, but it doesn't really matter. Every section will have its primary key. Thank you. You launched PSQL through round-con utility and you transferred the context. So, if we launch in the system with SELinux, if we launch PSQL, context will not be transferred. Well, it will receive the context. That's a good question. Round-con in production mode should not be used. So you logged in and you launch the application by the SQL and the context will be transferred. That is why it was necessary to introduce SELinux login. It connects security contexts and a simple login in Linux. A user can have a range of levels and categories. And if network client connect happens, how is context transferred? Net label gets the level and the category only. So, system U, and the type is netlabel PRT. So this user comes there. In etc SELinux context, there should be a table reflecting this context and the role and types, and the level and the category are not changed, so the context of security remains actually the duty of the client. The context of security doesn't change in terms of the level and the category. This is the last part of the context, and the role, user, and type should change. My database is on one server, and application is on a different server. I connect the base. The user is from Postgres. It's not SELinux user. So, it is not associated with the user of the operating system. The system knows nothing about it. It connects through Postgres protocol to Postgres. And so, how will it get its security context in this case if application cannot initiate this context? Well, first of all, it's necessary to have initialization of security context for application by all means. You will get a message stating that I'm unable to get peer label. It means that it cannot get the label. But the server with an application should be set in a similar way in terms of security context. Yes, RAMCon is actually the simplest example of a setting. Hello, my name is Dmitry Voronin. I used to work in SELinux Postgres, and now I use our own PPKT, and my questions are as follows. The first one is, will you certify? Will you certify secret information? Second one, were SELinux policies improved for them to work in a better way in your example? And the third one, it's just a comment. When we worked with the protected database, we tried using errorless. We wanted to write comparison rules, and it turned out that actually it becomes about 10 times slower. That's why it was decided to filter the records at the level at the low level rather than preparing a policy. Thank you. So, regarding certification, well, step by step we will do it. This is a search solution, and the final solution will have more performance and it will be different in terms of architecture. Indeed, the most convenient way is to locate the label in the string. On the other hand, looking at the evolution of the Postgres, vanilla Postgres and RLS shows us that we need to use RLS. This is a more universal and flexible mechanism. I can answer the second part of the question. You know, Dmitry, sorry. It's not fortuitous that I told you about this hermetic function. Indeed, we need to be able to use the planner. This is a recommendation. That is the first issue. Moving it downwards, well, if we move it downwards, the solution will become less flexible. Actually, a similar work had already been conducted. I showed it already. And it's necessary to store the label in the string, and it should be short. So, that's it.